All right, this is technically still connected to the last video, but we will add it to the next one. At the bottom of page 517, they talk about the period of a function and how our b value affects our period. So with sine, cos, and tan, whatever your b value is, that b value will always affect your period because it'll make either a horizontal stretch or compression. And the period of both sine and cosine is normally 2 pi. So now your period with a b value, because you multiply by the reciprocal, you get this beautiful formula that your period is always 2 pi divided by your b value. And for tangent, you get the same nice formula that your period is always pi divided by your b value. These are very useful formulas that you will use a lot that are not on your formula sheet because they're just connected to horizontal stretches and compressions. So we have the formula once, where its period equals 2 pi over the b value. If you rearrange that formula, because sometimes you'll get a graph and you'll have to find the equation, then it's nice to know that your b value is always 2 pi divided by your period for y equals sine x and y equals cos x, and your b value is pi divided by your b value, for your y equals tan x graphs. We got this period is 2 pi over b because this is horizontal stretch or compression. You're going to multiply x by 1 over b. And if your period was normally 2 pi, and then you multiplied it by 1 over b, the formula, this is 2 pi over 1. How do you multiply fractions? Now your period becomes 2 pi divided by b. Oh wait, next we look at the c value and how that affects our graph. So now we have a sine b in our transformations. In our transformations, we know that inside the function is horizontal. So if we had y equals cos x minus pi over 6, we could label this as a horizontal translation. X's are liars. You would go pi over 6 to the right. Excellent. So that's our, in sinusoidal graphs, it sometimes refers to as a phase shift. It's the same idea as a translation. We have a translation, pi over 6 to the right. So then in part B, it says, sketch the graphs So I'm going to start by sketching the graph of cos. Cos has an amplitude of 1, so it goes up to 1, down to negative 1. The period is 2 pi, so I'm going to label my axes family. There's my axes family. And I'm going to draw cos x with a dotted line in green. So coast starts at a maximum, then center line, then minimum, then center line, then back to maximum. There's my coast graph in green. And for phase shifts, we will usually draw the phase shift on the same graph. So I'm going to switch colors and go to a solid line. And the trick or the shortcut for drawing the phase graph is you have to figure out where pi over 6 is. Okay? Sometimes it's helpful to think of your unit circle. Pi over 2 is 90 degrees. Pi over 6 is 30 degrees. Does it make sense to you that I should label pi over 6 as 1/3 of the way to pi over 2? Because 30 degrees of 90 degrees is 1/3. Or 1/3 of pi over 2 is pi over 6. So the shortcut for shifting something to the right is we are going to take this little distance that I measured and move all of our ticky marks over that distance. You don't even have to label them. Once you've labeled one of them at pi over 6, by default, the other ones are labeled as well. And then, for a shift of pi over 6 to the right, we have our original graph in dotted line in green. I can now just take this point and shift it over. Take this point, shift it over, take the minimum, shift it over, take the middle, shift it over, and take the maximum and shift it over. And my graph will look like this. On my tests, and usually on the provincial final, you will get this question, and they will say for at least one period. So what we've done by drawing all 5 of those points, that draws at least one period. Putting arrowheads on says that it continues forever. Now the textbook in this question, if I answered exactly the way I answered, and the exam gave me the textbook question, I would lose an E8 error for domain, because the textbook said only draw it from 0 to 2 pi. So the fact that I went on 2 pi with my arrowhead technically would lose marks. This is, again, getting used to how questions are fussy. Right? So after you do the questioning, you do it right, then you look for the fussy things, like what kind of details. So technically, I would have to take out my eraser and stop right there. Same thing for my, nope, that's too far still. To stop right there. So my graph would stop below, and then on this side, I would have to stop there, because I can only graph it exactly from 0 to 2 pi. That's the textbook being fussy in this question. Okay? Generally, so in your homework, if you want to always just graph one period and put arrowheads on there, I'm fine with that, even if they have, like, personally, if they do something like this, feel free to put a line through that and change it to for at least one period. If you want to do that for your homework, I'm fine with that. Okay? So it's good practice to add the arrowheads on and graph it for one complete period. The questions that we can do here, now you can circle all of 3, E, and F.